Okay, hello. Yes, tell me which problem.
مش بروبلم. انا في كونسبت تبع ال
Okay.
tangential and normal forces. هيدي التانجنت ما بعرف شو equal ل r over d r over d تتا، ما بعرف امتى بنستعملها وكيف.
Okay. آه هيدي مش باليو ان يو تي التان بساي equal r over dr by dt. هيدي بcylindrical coordinates. Okay. What
اوكي.
is the idea? The idea is that in cylindrical coordinates, you define a certain origin. Okay. You consider a reference line, and wherever is your point P, you consider that UR is defined by the unit vector of OP. So if I want to draw it, it's along parallel to OP, same direction, same sense, but magnitude 1. This is UR. And for U theta, once you define the positive direction of theta, you turn in the positive direction 90 degrees, you get U theta. Okay? And
اوكي.
U z is
وتتا كل مرة تتا كل مرة كلوك
مش
versus
كل مرة
clockwise.
كاونتر، لا فينا أعطيك إياها كلوك وايز. إذا أنا
اه،
بالفيجر
كيف
أعطيك
بتقولي
theta
لنا؟
clockwise, you rotate from UR to U theta clockwise. Okay? If I give you this, I tell you this is theta. Okay?
اه اوكي،
Then
بتعطينا التتا.
yes,
طيب.
exactly. So if this is P, احنا عم نحكي 2D. In 3D بس شو بيزيد؟ بيزيد plus Z U Z. Okay, يعني you add a component along U Z. So this is
حلو.
UR, then and to get U theta, then you rotate clockwise, you get U theta. Okay?
أمم.
Now, let us consider 2D motion, for example. If you have in 2D motion, you have a certain path. So you have a path of motion, and you can write R as a function of theta. Okay? Now, the idea is that since you have R function of theta, it's easy to calculate AR and A theta from chapter 12. But what is complex is to project forces on UR and U theta, because in general, in majority of cases, forces are or along the tangent to the path or along the normal. That's why you need to define what is the angle between the tangent and UR. Yani here, if I consider this is the path of motion, at this point P, this is the tangent line. Okay. If you have
اوكي.
friction, for example, friction will be opposing motion along the tangent. So this is F. And to be able to project F on UR U theta, you need to know what is the angle between the tangent and UR. And this angle is called the psi. That's why you need to develop a formula to calculate psi. And from the
Sorry,
course,
the angle between the tangent وال UN.
will UR
UR. اوكي.
radial unit vector.
اوكي.
Okay. So psi is the angle from UR to the tangent line.
وليه بدنا اياه للانجل؟ لشو
بدنا
بدنا
اياه لانه
نستعمل؟
نحن مش بدنا نكتب sum FR equals MAR
صح.
و sum F theta equals MA theta. You need to
صح،
project
بصير عندنا
forces.
فورسز.
Yes. If you want to project friction, for example, how to project friction on UR U theta if you don't know the angle between UR and the tangent line?
اوكي.
This is the only reason where we need psi. So whenever you have a force along the tangent line or perpendicular to the tangent line, and you need to project this force on UR U theta, you calculate psi, because once you know angle psi, you can project F on UR and U theta, or the normal. And if you have the normal, which is perpendicular to the tangent line, let's say you
اوكي.
have the normal force. Okay, perpendicular to tangent line. So once you know that the tangent is doing with UR an angle psi, then between the normal and UR, the angle will be 90 minus psi. And you will be able to project N on UR and U theta.
اوكي.
Okay.
اوكي. وبس الكايناتيك kinematics
Yes.
using the chain rule.
You mean chain rule?
التشين رول
Yes.
بالكاينماتكس ما بعرف ما
Yes.
فهمت كثير.
How to when we use it?
هي عندها فورمولاز بس التتا الديريفاتيف تبعها شو اللي في او برايم او برايم برايم.
Okay, when? But let me know exactly what you are talking about.
اوكي بس يعني
Yes. هي بالchapter in the chapter or in
الشابتر
the review
13.
problems.
لا بالشابتر ريفيو بروبلمز ما رح اقطع.
طب يلا let me open the chapter. Chapter 12 you mean?
ايه في هالفورمولا تبع الاكسلريشن هي
Hmm.
ار برايم برايم تايمز يو ار بلس ار برايم تايمز يو ار برايم بلس ار برايم تايمز تاتا برايم. تاتا
Yeah.
برايم كيف يعني اذا مش تاتا هي بدها تكون انجل.
Theta is an angle and the derivative of the angle with respect to time. إذا أنت عندك theta, what is the derivative of theta with respect to time? It's d theta by dt. It's theta dot.
ايه
صح؟
صح بس تاتا شو بتكون عادة
theta هي الانجل between the reference line هلا حكينا عنها والvector OP يعني أنت عندك a path of motion. In URU theta coordinates to to find the position of a certain point P, you need to consider a reference point O, a reference line, any reference line, and then you say, I can determine the position of P from knowing the distance between O and P. I will call it R, and the angle from the reference line to OP. This is theta. So when you derive, when you write the expression of vector OP is R times UR. So when you want to derive the first time, when you want to get the velocity vector, you need to derive this term. Okay,
تاتا
and
هي equal ار يو ار او الار فيكتور هي الار يو ار.
our vector هي الار يو ار اللي هي
اه
OP vector.
اوكي
Okay,
اوكي
once
يعني
you
التتا دايما
derive
هي
يعني هون
يعني
عندك
تتا
U
هي
times V, U prime V plus U V prime. بس
صح
تطلع ال V ساعتها you derive to get acceleration.
اوكي
Okay, and
طيب
دكتور I
theta
have a
is the
question.
angle. Yalla, 1 second. So when you do d theta by dt, you get theta dot, which is the variation of angle with time. Yes,
صح
tell me. Yes.
تتا هي دايما الانجل between the reference line and the R vector.
مش ال I, OP vector.
R
R.
R
Yes,
R
R. Yes,
I
exactly.
said R.
Exactly, R. Yes. And if you have now, after a certain time, if P is now here, if you have P prime, then theta will become this angle from reference to OP prime. Okay?
Okay too.
Other
طيب ميرسي.
questions? Yes.
Doctor,
Yes, tell me now.
if I want to ask a question from the book, can you answer it to me right now or?
Look, which يعني I don't have يمكن the same edition now. If you want, we can open after the class. We can discuss it. Just send me a screenshot by email, and we can discuss the problem.
Okay, okay. Can I ask a generic question?
Yes, sure.
When we have a pulley, usually we indicate a datum and then we work, we
Yes,
take the distance or the coordinates from the datum.
exactly. Yes.
In some cases, for example, one of the exercises, a truck was going, a cable was connected to a truck, and then a pulley was connected to a trunk trunk,
Yeah.
and the truck was pulling the trunk horizontally.
Yes.
So I was a little bit confused how I need to take the datum because
Okay.
usually
I see what you mean. Look, whenever you have a motor, okay, let's say you
Yeah.
have a motor drawing a cable inward. So the coordinate for you, instead of being just rectilinear, It's a curvilinear coordinate. So you need to consider what is getting inside, what is enrolled in the motor. So you can take the datum any fixed point. You know, let's say you can take a fixed point in your figure. Okay, you take the reference at this level, and the coordinate should go from the reference towards the motor, because this coordinate will not represent actually the distance between this point and this one. No, it represents, if you want, what is this distance plus what is getting inside, and what is getting inside is varying with time. So this coordinate will represent what will be enrolled in your motor, but just instead of pulling straight forward, you are pulling by turning it around the motor. Okay.
Okay. So I always take a fixed point and then the distance
And
towards
then the vector towards the motor drawing the cable.
okay, which is always the case.
Yes.
Okay, thank you.
Doctor, I have a question about the data on the
Yes.
review problems exercise 10.
exercise 10 يلا
دكتور
chapter.
بس هيدا السيشن حتكون بس السيشن هيدي حتكون بس questions يعني ما
Yes,
في شي حتحليه
because look, already all problems are solved. All problems are solved. يعني أنا بدي to tackle your questions. معكم كل ال recordings. You can do the problems, do them and watch the videos, and then put your questions. In this way, we can profit more from the sessions online, to not repeat something that is already there. And you have the recordings, you have explanation for everything. I want just to answer your questions. Okay?
Okay.
And if you have a problem that you watched in the video and you didn't understand, we can repeat it together, of course.
Okay.
Yes, chapter 12 or 13?
12, exercise 10, please.
Exercise 10. Yes, okay. So this is what your friend was asking about, okay? Look, what do you have in this problem? What is new is that you have motors drawing cables, okay? So you should ask yourself first, what are the moving parts here? You have your motor is drawing the cable in a way to displace this upward, okay? So first, this beam will be displaced. So you need to take, and it will displace vertically. So you need to take a reference line. You can take the reference line here because it's passing by the center of the two fixed pulleys, okay? And then this is the first coordinate. Let us call it S of C. You can take it from upper level, or you can say also, let me consider it from here. Both are right. Why? Because the difference between these two coordinates is just a constant. So it will cancel out when you derive. Okay? Now, what is happening also is that instead of having, imagine that you have here a hand that is pulling the cable in this direction. If you have a hand here, you will put a reference line that is vertical and take a coordinate towards your hand. Now, instead of having your hand that is pulling straight the cable, you have a motor that will draw it inside. So just instead of having a rectilinear cord, it will be curvilinear. It will enroll in the motor. That's why you need one coordinate for motor A, SA, which represents the total length of the cord, this one, plus what will come inside. And the same for B. B also is drawing the cable. So you need to consider a coordinate to calculate the total length enrolled in motor B. And therefore you need three coordinates here, SA, SB, and SC, okay? And once you do this, you express the total length of your cord. This is a constant. So it will go with the derivation. You have SC plus constant plus SC another time. So until now, 2SC. You have also here a constant because these two levels are fixed, plus SA. And if you continue from this side, you have SC plus constant plus SC plus constant again plus SB. So in total, you have SA plus 4SC plus SB equal to a constant. Okay?
بس دكتور ال SA وال SC هن moving horizontally ما هيك؟
مظبوط. ال SA وال SB
اوكي.
moving horizontally بس بيبرموا على الموتور بيبرموا.
ايه بس مش نحنا قلنا انه اذا في movement horizontal
ما
لازم ناخد الدايتم vertical؟
ما لحوا الدايتيوم طبعا. هيدا الدايتيوم ل SA هيدا الدايتيوم ل SB بس الدايتيوم ل SC horizontal.
يعني مش هيدا الدايتم هو تبع كلهم.
هيدا
اوكي.
بس للSC. الدايتيوم اللي انت عم بتقولي عنه هيدا only for
ايه
SC. اوكي. بينما if you look at the figure بس خليني محيطها تشوفيها. It's not clearing. Let me use another color. هن حطوا لك هيدا اللاين. This line هي الدايتيوم of SA and this line is the datum for SB while this one is just for SC. Okay.
اوكي. thank you.
Welcome. Other question?
أنا I have a question about another exercise بس
يلا
إذا
tell
حدا
me.
بده يسأل
لا
قبل.
continue, it's fine. يلا. Which problem?
بالexercise 12
Yes.
الexercise 12 طالبين منا هو إنه نجيب
Relative velocity و acceleration. Yes.
acceleration تبع B relative to car C.
Yes.
ما كتير فهمت كيف أخدوا الأنج إنه UT و UN لأنه هو هي
يلا
يعني
I will explain it. Okay. You want to find velocity of B and acceleration of B relative to C. Okay. So first, you should say I need to get an expression for velocity of C and velocity of B. Then apply the relation that velocity of B is equal relative to C is equal to VB minus VC. Okay. And I will do the same for acceleration. So I will do acceleration of B relative to C is AB minus AC. So now to be able to answer the question, I should first express the velocities, the absolute velocities and accelerations of points B and C. Okay. So first, if you look at C, C is really simple because C is doing translation. And according to your figure, if I take this is I vector, if this is I, and this is J, okay, you can easily express velocity of C as minus 30J and acceleration of C as plus 3J, okay? So for C, it's simple. Now, for B, it's more challenging because B is doing a curvilinear motion. And in curvilinear motion,
بعتقد إني أخدين الجي لتحت لأنه C decelerating.
مش مشكل. You can take G لتحت. You can do what you want. As you put your frame, okay, if you put your frame in this way, then you take the opposite, يعني V positive, A negative. Okay? طيب خلينا ناخد مثلهم if you want. If we take J downward, so V of C is plus 30J, acceleration of C is minus 3J. Okay? Next step for B. B is doing curvilinear motion. And since I know the radius of curvature and I know the velocity and tangential acceleration, it's easier for me to express first the velocity and acceleration in tangential coordinates. But I cannot keep them in tangential coordinates because at the end, when I do VB minus VC, they should both be expressed function of I and J. Okay? So first, since you know the component of AB and VB along U and UT, you find them. And for example, you say first, how is my UT vector It's tangent to the path. Tangent to the path, so it's along the velocity. This is ut vector. And how is un vector? It's perpendicular to ut, directed towards the center of curvature. So this is my un. Okay. And now we can say that the first velocity v is equal to velocity magnitude, which is 15, times ut. But now you cannot keep it in this way because you need to do vb minus vc. You need to express ut function of I and j. And you can do this in a very simple way because, you know, look at the figure. You know, this is 30 degrees. Okay. The angle between the horizontal and the radius is 30. And since ut is perpendicular to the radius, so you can say if this is 30 here, what will be the angle between ut and I? If this is 30, the angle here will be 60. So if I want to present ut on my ij frame, it will be like this. This is ut vector, and it's doing with I an angle of 60 degrees. So how you can project now ut? You can project it on I and j. The magnitude of ut is 1. So you do 1 cosine 60 in I plus sine 60 in j. And you can replace your ut vector by cosine 60i and plus sine 60j. Okay. In this way, you can convert your vector back to ij frame. And you will do the same for acceleration. And your acceleration now will be expressed in ut and un. What can you say about acceleration of b? It's ab tangential plus ab normal. AB tangential, according to your figure, is opposing ut. It's minus 2. So you can say that AB is minus 2 ut. Okay. Plus VB square over rho un plus.
Why it's minus AB?
Why it's minus? Because look at your figure. ut will always follow velocity vector. The velocity vector is downward. While according to the figure, 2 meters per second square is opposing the velocity. Yani it's opposing ut. So it's negative along ut. Okay?
اوكي مش يعني انا بس يكون عندي هيك باخد A times V is negative here, so بقول إنه deceleration, we don't have acceleration.
Exactly. Whenever you have V and AT opposite, okay, and since ut always follow V, so since AT is opposite to V, then AT is negative. لأنه in UT always follows V. You never have V negative. V is always positive in UT coordinates. Yani V is plus 15 UT because UT is by definition the unit vector of V. Okay, it's not like an IJ or 1D motion. We said you can have positive V, negative V. And to say it's acceleration, A and V should be or both positive or both negative. And here in curvilinear motion, the condition is AT times V, okay? When it's positive, it's acceleration. But since V is always positive, then to say it's accelerating, AT should be positive. To say it's decelerating, AT should be negative. While in single coordinates, let's say AX, VX, they can both be positive or both negative to have acceleration. While here, acceleration means AT positive, deceleration means AT negative. Because UT always follows V. Okay?
Okay, it's you, doctor.
Okay. So it's
Can I ask another question?
Yes. Is it clear how we continue here? And you do VB
Yes,
square?
doctor, thank you.
Okay. Yes. Okay. Yes. Other question. Tell me.
Here the same question. دكتور ليه أنت حولت ليه أنت يعني we can express VA VB and ABA and AB and AC بالtangential normal.
You can do this.
بس إنه
بس
يعني
in
نحن ساعتها
general,
نعتبر
look,
C بس عندك
in general, ut, un will vary with position, while ij are always fixed. So this is why in general we express in ij, because it's a fixed frame, while un, ut, for each new position of the car, you have a new un, ut.
Okay.
Other question? Dear students, any other question on chapter 12 review problems, or any question in the course material, whatever is not clear for you, we can repeat it.
دكتور، ما بعرف،
Yes.
أنا كان عندي سؤال بإكسرسايز 3، بس هو عن إنه كيف لقيوا تي برايم، مش عن الكونسبت يعني، بس عن
مش مشكلة،
إنه ما
بدك
فهمت كيف.
بأي chapter 12 or 13?
إيه هون 12
Okay.
إكسرسايز
Problem is 3. Yeah. Yes, tell me.
تحت هو إنه بدنا نلاقي قد ايه التي برايم، قد ايه الفرق بين الوقت
Okay.
اللي لازم نجيب ال A وال B،
صح.
وبدنا نحط إنه الإيكويشن تبع البوزيشن أوف A ونحطها إيكوال تبع B، بس
Okay.
ما فهمت كيف طلعوا لقيوا التي برايم، ما فهمت كيف حلوا لهيدا الإيكويشن لقيوا التي برايم. إنه
Okay.
جربت أعمل ما
Yeah,
فهمت.
I will tell you how. Okay. خلينا بس تيفهموا الكل شو عم نعمل. In this problem, we have two particles, A and B. Okay? And both are ejected with an initial velocity V0, but at different times. يعني أول شيء كبينا A, and after a certain time, هلا هون هن شوي الأسامي سائلين، يعني هن التايم سموه T prime، والelapsed time يعني between the two launching سموه T. Okay, يعني إذا بدكم T actually represent here delta T, which is time elapsed between launching A and launching B. Okay, and they want us to know what is the time when the two balls will pass each other, and we want to find also the velocity at this instant. This is the question. So we want to find an expression of the time where the two particles will meet, function of t, which is the elapsed time, اللي هو delta t if you want, okay, and function of course of the initial velocity v0. This is the question. So first, if we do a small analysis, this is projectile motion. So A will move under the effect of gravity only. The same for B. So because you gave it initial velocity, it will move upward, it will reach a maximum height, then it will move down. And since B have the same initial velocity, there is a certain elapsed time between A and B. So after a certain time T, we launched B. When they pass each other, B will be in the phase of motion upward, while A will be in the phase of downward motion, to be able to meet each other, to pass each other. Okay. The question is to determine the elapsed time from the instant ball A is thrown to when the balls will pass each other. Okay. And to find the velocity at this instant. This is the question. Okay. So to do this, we know that when the two particles will pass each other, what is the condition? The condition is that y of A is equal to y of B. So all we have to do now, okay, is to write the equation of motion of A, write the equation of motion of B, and say that when they pass each other, YA should be equal to YB. Okay, and we need to express this time when they pass each other T prime, function of the elapsed time between launching A and B, function of delta T, and function of course, the initial velocity V0. That's why the first step will be to write the equation for A and B. Okay. To write the equation first for A, it's very simple. It's projectile motion. If I take the origin here and I consider that at t equals 0, we launched A. Okay, what will be then the equation of A? We know that it's half A y t square. And what is A y? It's minus g, because this is y axis and it's projectile motion. So the only force acting on the particle is the weight. So we have minus half g t. But please pay attention here, because they already used t for delta t for the elapsed time between A and B. Then we'll choose another name for time. We'll call it t prime. And minus half g t prime square, okay, plus v0 t prime, okay, plus ya0. Ya0 is 0 because we started from the origin. So this is the equation for y of A. While for y of B, you should pay attention to take into consideration that that we launched B after t seconds. So to give you an example, let's say we launched A at 0 seconds. We launched B for t prime equal to 2 seconds. Okay, this means that the elapsed time for B is the time t prime minus 2, because at 2 seconds B will start motion. And when t prime is 2, this is the origin of time of B. For B, the time of B will be 0. So I should subtract 2 from the total time to get what is the time of motion of B. That's why I should replace in the equation of B, I should replace t prime by t prime minus 2. So I will have to write minus half times g. Instead of t prime, I put t prime minus t, and the elapsed time between the two launching, okay, minus t square.
دكتور بس مش هي البي كبيناها بعد الاي؟
إيه بعد الاي؟ شو يعني؟
إيه.
انت الكرونوميتر بعده ماشي صح؟ انت
إيه.
مشيت الكرونوميتر كان 0. يعني اذا الكرونوميتر قال صار مارق 10 seconds، بيكون قد ايه صار له اي ان ار؟ 10 seconds. بينما انت اذا كبيتي بي على 2 seconds وصار الكرونوميتر 10، قد ايه بيكون صار له بي ان ار؟ 8 seconds. 10 minus 2. Okay, so the time of B, the time of motion of B is the time of motion of A minus the elapsed time.
اوكي.
بينما لو كبيتي before كنت عملتي plus.
اوكي.
Okay, this was your problem. ليش حطينا minus؟
لا my problem كان انه ما عرفت حل الايكويشن بس.
ما بدها شيء الايكويشن. look حتى بالفيديو عملتها in detail. تعملي plus v0 t prime minus t. اوكي، هلا شو بتعملي؟ شو الانون تبعك in this equation؟ انت you want to express t, you want to find you want to find t prime. هيدا الميتينج تايم، اي متى بيتلاقوا. you want to express t prime meeting اذا بدك when they meet each other ya equal yb. you need to express t prime of meeting function of v0 and g and t. okay, when you expand this يعني بس هي mathematical expansion. هون بتعملي second degree a minus b square هي a square minus 2ab plus b square etc. when you develop okay حيروحوا ال t prime square، هيضل لك بس expression for t prime meeting function of t. يعني just it's a simple mathematical development to get an expression of t prime function of t. وبيطلع ساعتها معك the following relation. بدك اعمل لك اياها in detail I can't do it. بس
لا دكتور لا برجع انا بعملها.
okay. بس this is the technique. Okay.
Okay, thank you so much.
Welcome.
Doctor,
Yes.
per cylindrical components,